we will start Isolation of Elements, that is Unit 6. Elements available in free form in nature are metals, gold and copper. Non-metals, carbon, sulfur, oxygen and nitrogen. And inert gases, helium, neon, argon, krypton, xenon. Metallurgy. It is the science with the help of which isolation of metals from their ores and minerals. Mineral. Then available in nature in earth crust, which is having proportion of metal very less. Ore. A mineral which is used to extract metal. So with reference to this, we can say that all ores are minerals, but all minerals are not ores. Gangue. Gangue is undesirable substance or impurities in ore, which we have to remove. Gemstone. Well, in some cases, impurity forms produce different color, and these kind of stones are called gemstones. For example, ruby, which is having impurity of chromium. Sapphire, which is having impurity of cadmium. Emerald, it is also having impurity of chromium. So these are excellent stones available, and they are very precious stones. And these stones having different color because of impurity of these elements. Metallurgy. The first step of metallurgy is to concentrate ore, because ore is obtained from earth crust, and everything which is in the earth crust should be taken along with minerals and ores. So it is necessary to concentrate ore. To obtain ore by removal of impurities is known as concentration. There are different methods of concentration of ore, and one of the physical method is hydraulic washing. In this case, this is hydraulic classifier, and here through this pipe we can flow water, and the platform with wedges will be available. So, agitation of ore is strong current. In strong current of water, heavier particles of ore settle down in the wedges and they can be removed, and lighter particles of impurities are washed away. So along with the flow of water, lighter particles will be washed away, but heavy particles will settle on this platform along edges, and these wedges will try to hold these metals. These are heavy metals or ores. Second method is magnetic separation. Here, if ore is having magnetic property or gangue is having magnetic property, then this method is used. This is a conveyor belt with its magnetic roller, and powder ore is charged on this conveyor belt. When this powder ore passes through this edge of the wheel, well, because of magnetic property of wheel, the magnetic ore or magnetic particles remain with the wheel, and non-magnetic particles fall. So non-magnetic particles can be collected in one container, and at this level magnetic particles which will leave this oil and conveyor belt, and you can collect them over here. Next method for concentration is froth flotation method. In this, first of all, normally this method is used for separation of lighter ores of sulfide. So take beaker in which ore is kept. Along with this ore, we have to add water, xanthates, and some pine oil and froth stabilizer like cresol, aniline, etc. This is all mixed, and then we have to pass compressed air through these pipes, and when air comes out, and due to agitations, it produces froth. Along with the froth, the sulfide particles, which are very light in weight, will come on the surface, and that you can collect, and heavy particles of gangs will remain on the bottom of the beaker or vessel. So froth flotation process for the concentration of sulfide ores.
This is a method of concentration of ore used exclusively for sulfide ores. Principle involved is the difference in the wetting properties of the ore and the gangue particles. The sulfide ore particles are preferentially wetted by oil, while the gangue particles are wetted by water. A mixture of water and pine oil is taken in a tank. The powdered sulfide ore is dropped in. Compressed air is blown in through the agitator. The agitator is rotated several times. Froth-containing ore starts rising up. The impurities settle down and are let out through an outlet at the bottom. Froth is dropped into a settling tank where the pure ore sinks to the bottom. Thus, the concentrated ore is ready for further processing.
So with the help of froth flotation method, we can separate sulfide ores. If more than one sulfide ores are present, then a substance is added called depressant. For separation of lead sulfide and zinc sulfide, we can add sodium cyanide. So here sodium cyanide is depressant. Sodium cyanide reacts with zinc sulfide and produce complex, that is sodium tetracyanozincate 2, and lead sulfide is remain in the solution. Then lead sulfide can be removed with the help of froth. Next is leaching process, which is also one of the chemical method for separation of is one of the chemical method for concentration of ore. This method is used when the ore is soluble in some suitable solvents. For example, purification of bauxite. Bauxite, which contain many impurities, which is treated with sodium hydroxide solution at 150 degrees Celsius, Al2O3 reacts with sodium hydroxide and produce complex sodium aluminate. This is soluble in water. So this is separated and then it is heated with aluminum hydroxide. Sodium aluminate is heated with aluminum hydroxide and we will get aluminum hydroxide. Sodium hydroxide remain in the solution. Or Sodium aluminate is treated with carbon dioxide, which also produces aluminium hydroxide, and sodium bicarbonate. This precipitated aluminium hydroxide on heating gives alumina. This is pure alumina or pure bauxite, and here this process is leaching. Some other processes are also used, for example, leaching of silver or gold ore, and the process is known as cyanide process, in which metal is treated with cyanide ion in presence of air and water, and it produces cyanocomplex of metal. This cyanocomplex of metal is treated with zinc. Zinc has more tendency to donate electron. Therefore, metal is replaced by zinc, and we will get a zinc complex and metal will be free. For example, silver cyanide, which is treated with sodium cyanide, it produces a complex of silver cyanide and then add zinc. So silver is removed and zinc will join with cyanide ion, and this way we can separate silver.